Hello, good day to each and everyone. It has been a long time since we have last seen each other. So let us take this opportunity once again to learn something and to embark on a new journey towards learning some important concepts in science. So just sit back, grab your pens as well as your notebooks, and get ready to jot down some important informations that I will be sharing with you for this lecture video. So without further ado, let us begin with our discussion. In today's lecture video, I am going to specifically talk about the different types of chemical reactions as part of our discussions for Module 3. So in this particular discussion, we will be talking about different types of chemical reactions as well as how is the law of conservation of mass is observed when we balance and write a chemical equation from a chemical reaction. So in order for me to start our discussion for this video, let us now share our screen right now. Okay, so we will be dealing with the following objectives for this discussion. So first, we will be citing evidences of chemical reaction, as well as identify and as well as classify the different types of chemical reactions. Then another, apply the principles of conservation of mass in writing and balancing chemical equations, and as well as explain the importance of chemical reaction in the formation of new substances. So just an important information, this will be a two-part video wherein in the first part, which is what I'm recording right now, we will be dealing with the different types of chemical reactions, while on the second part, we will be talking more about how to balance chemical equations from chemical reactions. So let us now begin. But first, let us try to ponder on this important question. What is a chemical reaction? And if a chemical reaction does occur, how do we know that a chemical reaction has taken place? So for us, maybe some of us, no, we have already ideas on what a chemical reaction is, right? We already have some ideas what are some of the evidences or indicators that a chemical reaction has happened. So there are some clear indicators that we can observe that a chemical reaction has happened. For example, a change in color of the material, emission of light, temperature change or the change in temperature, whether it became hot or became cold, the evolution of gas or the production of gas molecules during a reaction, precipitation. So you might be confused here. Precipitation is not the same as the precipitation in the water cycle. When we say precipitation here, that is a formation of a solid insoluble substances when two solutions are mixed. Okay, so we also have change in voltage, which is not that observed by our senses, but we usually use some instruments for that one in order to detect these changes in the voltage of reaction. So some of the examples, like for example, in the change of color, when you mix HCl with the solution of cobalt nitrate, then we also have here in the precipitation, the precipitate between sodium dichromate and lead nitrate. So you can see there, the precipitate there is the yellow foggy-like substance that's settled at the bottom. Then we also have the formation of bubbles when calcium reacts with water. So another one is a very common example, the production of heat when methane reacts with oxygen. Okay, then another thing is that we have to know what is a chemical reaction. So when you speak of chemical reactions, they are referred to as the process in which atoms of the same or different elements rearrange to form one or more new substances. So they may react with one or two atoms of the same element or one or two atoms of different elements. So they rearrange their compositions in order to form one or more new substances. So that's what a chemical reaction is all about. And usually, chemical reaction is represented by a chemical equation, which shows the reactants, which are usually written on the left side of the equation, and as well as the products, which are usually written on the right side of the equation. So reactants are the chemicals involved in a chemical reaction, while the products are the substances that are produced from that reaction. So to show you that one, let me give you an example. So for example, this is a very common reaction in the photosynthesis of plants, wherein carbon dioxide and water yields glucose and oxygen, right? So this is the reactant side, is on the left side, and usually we denote the arrow as yield. Okay, that means it is read as yield. So every time you see an arrow in the chemical reaction, that means yield or produces. Okay, so products. And as you can see there, you might have noticed that there are some numbers written either as a subscript or a coefficient. So the coefficients here are as follows. As you can see, these are the coefficient there, and these are the subscripts here. And chemical equations usually observe this, what we call as the law of conservation of mass, wherein the mass of the reactants is always equal to the mass of the product. So it can also be interpreted as the same number of atoms of each element in the reactant side and on the product side, which we will be dealing with in the next video that we are going to tackle for this one. So now there are mainly 1, 2, 3, 4, 5, 6 types of chemical reaction, and they are denoted by these general equations here. So I want you to take note of these general equations. So for combination, or we call them as synthesis, A plus B yields AB. Okay? Decomposition reaction is the reverse of combination, wherein AB yields A plus B. Then we have here the single replacement reaction, AB plus C yields AC plus B. So as you can see, there is an exchange of partners in this reaction. Now in the double replacement, AB plus CD yields AD plus CB. So that's another type of reaction. We also have the combustion, wherein a hydrocarbon, when it reacts with oxygen, it always yields CO2 and water. Then we also have the neutralization reaction, or in other books you may refer to this as an acid-base reaction. Like for example, HCl plus NaOH yields NaCl, which is a salt and water. So let's deal with them one by one. So when we speak of combination reaction or synthesis reaction, this is a reaction wherein two or more simple substances combine to form a more complex substance, which is generally referred to as the product. So in symbols, A plus B yields AB. Okay, that's what a combination reaction is. So example, so let's say when a metal reacts with a non-metal, they always form a binary compound. So when you say binary compound, they are composed of two atoms of different elements. Okay, like for example, oxides, sulfides, or halides. So let's say, for example, when a magnesium reacts with sulfur, it yields magnesium sulfide. So that's in symbols, Mg plus S yields MgS. So this is now your chemical equation for that. Okay, and another common combination reaction is when you combine a non-metal with oxygen, we will form a non-metal oxide. Like for example, when a sulfur is added with oxygen, it yields sulfur dioxide, or we call it as S plus O2 yields SO2. Okay, another common combination reaction is when a metal oxide, so when you say metal oxide, that is a metal plus an oxygen, when they are reacted with water, it yields metal hydroxide. So like for example, a barium oxide plus water yields barium hydroxide, or BaO plus H2O yields Ba open parenthesis OH close parenthesis with a subscript 2. Okay. Now, another common combination reaction is a nonmetal oxide plus water yields an oxyacid, or shall we say an acid in general. So like for example, a sulfur trioxide with water yields sulfuric acid, which is a very strong acid in general. Then last one, we have a metal oxide. When combined with a non-metal oxide, they yield salt. So for example, barium oxide plus sulfur trioxide yields barium sulfate. Okay, so those are some of the examples of a combination reaction. So the bottom line here is a combination reaction is always composed of two or more reactants on the left side and usually forms a single compound on the right side of the equation. Okay, so I hope that you will take note of that key indicator. Okay, now another type is what you call as decomposition reaction. So in a decomposition reaction, this is what you call as the reverse of combination reaction. So the reactant decomposes into two or more substances, and the addition of heat, by the way, sorry for the typographical error, that is supposed to be heat. Okay, so that's supposed to be heat. So usually in a decomposition reaction, heat as a catalyst of the reaction is usually involved in order to decompose the substances into its simpler substances, and this is usually represented with AB yields A plus B. So in here, AB, which is a single product, is considered as the reactant. Now, it decomposes, and the products now are the components of these reactants from the left side, which is A plus B. So let's look at some examples for that. Like here, when a metallic carbonate, let's say metallic carbonate is a compound with a carbonate ion, it decomposes into metallic oxides and carbon dioxide. Like for example, when sodium carbonate decomposes, it is decomposed into sodium oxide and carbon dioxide. Okay. Now, when metallic chlorates also, or shall we say a compound with a chlorate ion or ClO3, decompose into metallic chlorides and oxygen. Like for example, potassium chlorate decomposes to potassium chloride plus oxygen. So, and another example, when some acids decompose to form non-metallic oxides and water. Like for example, for carbonic acid, it decomposes to carbon dioxide and water. Okay, and there are some decomposition reactions also caused by the passage of electric current. This is called as electrolysis. This is a classic example. Let's say for water, in order for you to decompose the individual components of water, which is hydrogen and oxygen, you need to introduce electricity for it. So with the electricity as their catalyst for your reaction, you will yield H2 plus O2, or hydrogen and oxygen in the product side. Now, another type of reaction is what you call a single replacement reaction. Now, in a single replacement reaction, this is a very special type of reaction because it takes place when one element, either it could be a metal or a non-metal, is displaced by a more active element. When I say displaced, they are replaced by a more active element to produce a single element and a compound. So this is usually represented by this equation: AB plus C yields AC plus B. So take a look at this representation. As you can see, AB is a compound and C is an element. And if C, let's say for example, if C is more active than B, then it has the ability, or shall we say, it has the capability to replace the compound or the element in this compound AB. So when that happens, B and C, or C replaces B, it becomes A, C, and what happens to B is that it is separated as a single element. So that is what a single replacement reaction is all about. So, but how does that happen, sir? How does single replacement happen? Or how do we know that an element is more active than the other element, right? So we have to take that into consideration. So we have here an activity series for metals. Okay, there. What is the activity series of metals for? It shows you the list of metals. The activity series of metals will show you which metals is more active than the other. So here is how you're going to use this. You can actually download this in any in any books or ebooks. If you have some textbooks about this which contains this, then you can also use that one. Me, I prefer to use this. This is from my textbook, but you can always have an updated list around the internet. But for uniformity's sake, so let's just use this one as our reference for this video. Okay, don't worry, I will be distributing this list to you, so you can use this for free. So let's say, how do you use this? As you go up to the list, going up to the list, it increases the activity of the metals. Meaning to say, the higher the metal is from the list, the more active it is from the lower metals. So for example, as you can see here, lithium is the most active metal from this list, while gold is the least active. Okay, so the further you go down from the bottom of this list, the least active the metal is. Okay, so you have to remember that one. You don't need to memorize this. Actually, I don't memorize this. You may just take a look at the list as your reference. Then aside from that, we also have the activity series for non-metals. So the same, as you go up to the list, the non-metals tend to be most reactive, while as you go down to the bottom, it becomes least reactive. Like for example, fluorine is the most active non-metal. Right? So this is how you're going to look at this list. So how does this relate to our discussion? So for example, a metal in a compound can be replaced by a more active metal. Let's say when you add potassium to a copper chloride, potassium is more active than copper. So when you do a single replacement reaction, K plus CuCl, which is the symbol for copper chloride, it now yields 2KCl plus copper. So how do you get a single replacement reaction here? So let's just imagine that this, from our symbol a while ago, this is A and this is B, right? And then this is C. Okay. So how do you do this right now? So as you can see, if you're going to compare the two metals, K and Cu here, if you're going to look at the list, potassium is more active than the copper if you check the table of activities for metal. So let's look at it again. Copper. Let's check copper. Copper is here. And if you look at potassium, it's on the top. And since potassium is much active than copper, then it has the ability to replace copper in the formula. So that is why you will see 2KCl here. So as you can see, Cl now has a new partner, which is K. Okay, I'm sorry. And now copper is now outside of the compound. So it becomes 2KCl plus C. Okay? So that's how you're going to look at it. Next, a non-metal can be replaced by a more active non-metal. Of course, it's also the same for non-metal. Let's say, for example, For bromine and potassium iodide, a potassium bromide and iodine is yield. So let's take a look at this example. Bromine and Ki. The nonmetals here, as you can see, is Br, which is bromine, and iodine. Now, if you're going to compare bromine and iodine here in this equation, you will see that bromine is more active than iodine if you check the table of activity series for the nonmetals. So let's check it once again. As you can see, bromine is here on this list, right? And iodine is here. So bromine is more active than iodine. So that means it has the ability to replace iodine in that chemical equation. So as you can see, in the product side, KBr is formed. And iodine is now outside of the equation or the compound. So KBr plus iodine. Okay, that's how you're going to check its applicability. Another one is if an element in a compound is made to react with a less active element, no reaction will take place. Now, let's say, for example, a copper and hydrochloric acid. There's no reaction there because if you're going to check copper here and hydrogen, copper is below the hydrogen in the activity series for metals. So let's check. You check, copper is below hydrogen. If you're going to check hydrogen, it's here, right? So hydrogen is more active than copper. So that means that if you're going to check again our equation a while ago, so let's check it again. Hydrogen is much active than copper. So copper, being the single element here, when it tries to replace H in the HCl, it will not happen because copper is less active than hydrogen. So that's why no reaction will take place for that. So since copper, again, is below the hydrogen in the activity series for metals. Okay? So that's how a single replacement works. Always remember to check the activity series for metals and nonmetals to identify whether the reaction will occur or not. So that's why it's important for us to familiarize ourselves with the activity series for metals and nonmetals in a single replacement reaction. Now, another type of reaction, which is of closer resemblance to single replacement reaction, is what you call as a double replacement reaction. Now, this type of chemical reaction usually occurs when two compounds react to form two new substances. And this is characterized by an exchange of ion pairs. So, in symbols, AB plus CD yields AD plus CB. Okay. Now, in this case, how does it resemble a single replacement reaction? In a sense that they exchange ions. But here in double replacement reaction, we do not actually need to use the what do you call this? The activity series for metals and nonmetals. Because in a double replacement reaction, the exchange of ions usually happens. So as you can see, AB plus CD, then exchange of partners occur, AD plus CB in the reaction. Okay? So that's how you're going to identify that that is a double replacement reaction. Let's say, for example, calcium carbonate plus sodium chloride yields calcium chloride and sodium carbonate. So let's take a look at it for example. This is calcium and this is carbonate. So in case you don't know what is carbonate, you check your periodic table of elements and check on the polyatomic ions. Carbonate is one of them. Okay? And NaCl. Let's label this as A. Let's label this as B. We will take carbonate as a single entity since it's a polyatomic ion. Okay? So we will call this as C and we will call this as D. So when an exchange of ions happen, what usually occurs is that A pairs with D and B pairs with C. Okay? So that's why in our final product here, Ca pairs with Cl So that's why it becomes CaCl2. Pero how CaCl2 is formed, sir? Yeah, now if you're going to take a look at in your periodic table, Ca has a positive 2 charge, right? And then Cl has a negative 1. So when an ions are exchanged, the subscript for Ca becomes 1, and then for Cl becomes 2, so it becomes CaCl2. So that's how it usually happens. Okay? So, and of course, let's not forget Na and carbonate. So Na2CO3. So how did it happen, sir? Now, if you're going to check your periodic table once again, Na is positive 1. Has a charge of positive 1. Now, CO3 has a charge of negative 2. Okay? Now, let's treat carbonate as a group, and let's have an exchange of ions here. 2 goes to the subscript of Na, and this positive 1 goes to the subscript of CO3. So when that happens, this is the result, Na2CO3. So that's why our final product for this reaction is CaCl2 plus Na2CO3. So that's how a double replacement reaction usually happens. So let's move on to another example. MgSO4 or magnesium sulfate plus ammonium nitrate yields magnesium nitrate plus ammonium sulfate. So, sir, it's so complicated, sir. Don't worry, we will dissect it into its individual components later. So as you can see here, let's take a look at this polyatomic anions for a while. I will put a parenthesis so that we can treat them as one group, so that later you'll be able to comprehend what I will be sharing to you. Okay, for example, we will treat this as A, we will treat this as B, we will treat this as C, and we will treat this as D. So again, when we look at double replacement reaction, A always pairs with D and B always pairs with C, so that when we identify the products of this reaction, A should pair with D. So as you can see, Mg should pair with NO3. So that's why you can see here MgNO3 with a subscript of 2. How did that happen? Well, it's very much simple. Mg has a positive 2 charge, while NO3, if you look at your periodic table in the polyatomic ions, has a negative 1 charge. So when they exchange ions, the charge of Mg plus 2 goes to NO3. So that's why it has a subscript 2 right now. And this one here, it's understood as 1 already. So MgNO3 2. Now, how about the other product, B plus C? So SO4 combines with NH4. So how do we know that it's NH4 subscript 2 SO4? Now, if you are going to look at our periodic table once again, NH4 is called ammonium in the periodic table. It has a charge of positive 1. Okay? While SO4 has a charge of negative 2 in the periodic table. Now, when they exchange ions, NH4 will now have a subscript 2 and SO4 will now have a subscript of 1. So that's why NH4 to SO4. And this is how a double replacement reaction typically happens. So we have so far discussed 4 types of chemical reaction. Now let's move on to another type of chemical reaction. So we have the combustion reaction. So a combustion reaction is a reaction that takes place when oxygen combines with a hydrocarbon or a compound that contains hydrogen and carbon to form. And usually, when they happen, combustion always yields water and carbon dioxide. So for example, C4H10 is methane, and when you combine it with oxygen, it becomes CO2 and H2O. This is, I think, the simplest reaction that you could think of, because every hydrocarbon, no matter how many carbons and hydrogens they contain, when they react with oxygen, they always yield CO2 and H2O. Okay, for example, above C4H10 is a butane gas. Okay, so when you burn a butane gas, it yields CO2 and H2O. Okay, so that's a combustion reaction. And the last reaction that I will be talking about is the neutralization reaction, or what you call as the acid-base reaction. Now, this type of reaction is between acids and bases. And this reaction results to the formation of a neutral product, which we call as salt and water. So when acid and base combine, it always yields a salt and water. So for example, this is a classic example of HCl, or we call this as hydrochloric acid. So in common name, we call this as muriatic acid. And sodium hydroxide, they yield sodium chloride and water. So in symbols, HCl plus NaOH yields NaCl plus H2O. Okay, that's a neutralization reaction. Now, the first thing that you may question about is, sir, how do we know if it's an acid or a base? Usually, an acid always contains a hydrogen plus ions written first in the chemical formula, like for example, in this case, HCl. That's an acid. I know that's an acid because there is an H plus ions here on the first in the written first in the chemical formula, and I know that it's a base because it contains the OH ions, which usually forms a base when it combines with metal. Okay, usually an acid doesn't contain a metal, while base, most of the time, they are always paired with metals and OH ions. So for example, what are some of the common acids that we can identify? Let's say H2SO4. This is an acid because there's an H plus ions first written in the chemical formula. We also have HF, which is the hydrofluoric acid. We also have HI, or hydroiodic acid, and we also many other acids that we can think of. NaOH, we have BaOH2 or barium hydroxide. Any compounds that contains an OH plus ion. So when they combine, they always form they always form a salt, no? And water. Okay, so all in all, those are the 6 types of chemical reactions that I want to discuss with you for this video. Now, knowing the different types of chemical reactions, very important, because it helps us to understand, it helps us to somewhat identify and predict possible outcomes of the reaction, and as well as identify the chemicals that are usually taking place in the reaction. So let's repeat once again. We have 6 types of chemical reactions, namely we have the combustion reaction, we have the combination reaction, we have the decomposition reaction, we have the single displacement, and then we have the double replacement. Then we also have the combustion reaction, and last but not least, we have the acid-base reaction. So just to test whether we have learned something out from that discussion, let us first answer this very simple exercise. Classify the following unbalanced chemical equations according to the 6 types of chemical reactions. I'll give you around 5 minutes to answer this. You may pause the video, but if you'd like to know the answer, you may continue watching this video. I'll give you a couple of minutes to think, and after that, we'll answer. Okay, For those of you who waited for the answers, let's reveal them right now. So for example, number 1, NaOH plus KNO3 yields NaNO3 plus KOH. This is definitely a double replacement reaction. As you can see, you have compound here and a compound, and they exchange ions. Okay, that's a double replacement reaction. Now, how about the number 2? CH4 plus O2 yields CO2 and H2O. Okay, this is a hydrocarbon, in very obvious. So, combines with oxygen, yields carbon dioxide and water. Yes, that is a combustion reaction. Correct. How about this one? Iron plus NaBr yields FeBr3 plus Na. Yes, that is a single replacement reaction. Correct. How about CaSO4 plus MgOH2? Oh, that's very simple. And again, if you answer double replacement reaction in number 4, you are correct. Okay, way to go. How about this? NH4OH plus HBr is H2O plus NH4Br. Oh, this is a bit tricky. You might be thinking that this is a double replacement reaction. Yes, it's actually a double replacement reaction. Now, but take a look at OH and H here. This is clearly a base, and this is clearly an acid. So when a base and acid combines, it forms a salt and a water. So you can also say that this is an acid-base reaction. Okay, because typically acid-base reaction is a type of a double replacement reaction. Okay, so but if we really want to be specific, this is an acid-base reaction, since acid and base are involved in this reaction. Okay, so how about this? Wow, this is also very simple. P4 plus O2 yields a single product. This is clearly a combination reaction. Okay, so we might forget to label them. Okay, let's just write this is double replacement, this is combustion. Okay, this is single replacement. Let me just write it in symbols. This is double replacement. This is again neutralization reaction. How about this one? This is a combination. Okay, combination. How about this? NaNO3 yields NaNO2 plus O2. Well, you got it right. This is a decomposition reaction. Decomposition reaction. Now again, number 8, you can see that this is a hydrocarbon. How do I know it's a hydrocarbon, sir? It is composed of carbon and hydrogen. Okay. Reacts with oxygen, yields CO2 and H2O. Then we also have this as a combustion reaction. Okay. How about this one? H2SO4. Ooh, this is again an acid, right? And this is OH, this is a base. So NaSO4, this is your salt, and this is H2O. So therefore, this is neutralization reaction or acid-base reaction. And last but not the least, as you can see, multiple ions are involved. This is clearly a double replacement reaction. So what's your score? So if you got 8 to 10 points, then that means that you have a clear understanding of this topic. If you got 6 to 7, your average. But if you scored over than 5, then maybe I suggest you may rewatch this video, or you may read your modules that I posted in our RLX CLA. Okay, so let me end this lecture video right now. So in summary, a chemical reaction takes place when there is what you call as rearrangement of 2 or more atoms of elements in a compound, and that they are usually classified into different types, wherein we identified them as number 1, combination reaction, decomposition reaction, single and double replacement. Then we also have the combustion reaction as well as the neutralization reaction. This ends our video for this. Okay? In the next video, I'm going to post on how to balance chemical reactions involving different types of chemical reactions. So for now, let us end this video, and I would like to say thank you for watching and listening our discussion for this video. So let us see you once again for another episode of learning in our next lecture presentation. Goodbye and take care always. See you next time.